Everyone, welcome back. Welcome back today. We're going to go into Battle 3 of Practice Exam 5 from JackWestin. So without taking my time, just remember your highlights. Always highlight new nouns, new names. First, I call them first encounter nouns. Highlight them and highlight subsequent information that really describe the noun. Forget about adjectives, forget about hyperboles, forget about anything that is not what the thing does or why the noun was mentioned. Right. So let's get into it. Researchers are developing a photon activated sensor robot. Well, usually I highlight the acronyms. I don't highlight the full name, but PASER to optimize real light intensity monitoring and control plant processes. So what does PASER do? It optimizes real-time light intensities. Okay? And this helps to monitor plant growth, right? Or is it a plant growth sickness? That's what it does. Now they're going to give us more information, right? So PASER is designed to detect light, but that's what it does. PASER detects light within the photosynthetically active radiation. Again, acronym spectrum. I think it's important. It's always good to know which section you are in, so you focus on the things that pertain to the section, right? Which is critical for plant photosynthesis. So from here, I've highlighted everything that describes PASER in the setting of plants. It describes the wavelength it works and all of that. To be deployed in greenhouses, PASER utilizes a photosensor-based circuit to measure light intensity. So PASER, we're still talking about PASER here, right? This is a photosensor-based circuit to measure light intensity. Try to keep it to always 3 highlighted things per sentence. This circuit converts incident photons into electrical signal proportional to light intensity. So the circuit, what does this circuit do? Converts the photons into an electric signal. And that electric signal is proportional to light intensity. What does that mean? It means that as the electric signal increases, light intensity is increasing. So we can measure light intensity by just focusing on that electric signal. The generator signal is then processed by blah, blah. I don't think any of this makes right. It's going, but I'll just say that it's processed, right? Generator signal is processed. I could highlight that or not. This will be fine. LDR represents a light dependent resistor. Acronyms are always, right? It's also the first account now. The resistance of LDR changes in response to light intensity. So we have it here, light gets in there, the resistance is going to change, and then whatever comes out is going to be measured and processed. That's great. The robot operates on a power drive derived from electromagnetic radiation of 2.4 kilohertz. That's important. Any numbers you see, I'll say try to highlight them, which induces a current within the circuit, right? So we have a frequency that induces a current. That's the highlight of that sentence. This current, so now we're going to be talking about the current, right? This current, typically around 15 milliamps, is crucial for driving the model and the internal processing unit. So the current drives the model and the internal processing unit. PASER transmits real-time light intensity data wirelessly to a central control system, facilitating dynamic adjustments to artificial lighting systems. You know what? I'll highlight a few things here, but looking at what we are dealing with here, I'm thinking, okay, they can ask me about current resistance. They could probably ask me about photon energy. Nothing of that sort is here, but let's just say what PASER transmit real-time light intensity data wireless. It's just because maybe they ask a question about that, right? This feedback loop ensures that plants receive optimal light. So basically what they're saying in all this is PASER transmits real-time light intensity to make sure that plants receive optimal light. And this optimal light for efficient photosynthesis, thereby promoting enhancement. So this optimal light enhances the of the plant, right? So you see, there's a whole lot of things they've written in here. Or what are they really trying to tell you? What is all of these words? What are they trying to say? Pacer, real-time light intensity data wirelessly. Why? So that plants receive optimum light and it will promote and enhance growth rates. Okay, experimental results indicate that Pacer can measure light intensity with an accuracy of this. It may come up, so we'll highlight anything with numbers. So measure light intensity. We're still talking about Pacer here, right? The deployment of multiple phases, each measuring 2 centimeters in diameter and 5 centimeters in height across a broad area, ensures comprehensive and uniform light coverage. So we have a diameter of 2 centimeters. It may come up, I don't know, and 5 centimeters high, right? Because we're in the Chem Phys section. So these things could be asked. We could be asked to calculate areas, volumes, I don't know, right? So now we are done. We have a sense of what Pacer does. Let's move to our questions. Light travels through a vacuum at the speed of 3 by 10 exponent 8 meters per second. Therefore, in a tent with a refractive index of 1.5 found in greenhouses, its speed would be. So this is pretty much a red flag question, right? It's giving us stuff in the question stem that were mentioned in the passage. That's what I'm saying is a red flag question. But what we need to remember here is going to be our formula for refractive index. Refractive index is going to be the speed of light in air divided by the speed of light in the medium, right? So we have the refractive index, we have the speed of light, we have these two. We are looking for V. If we make V a subject to this equation, this is what we get. We get 3 by 10 exponent 8 divided by 1.5. 15 goes into 30, 1.5 goes into this twice. So our answer has to start with a 2. The only answer that starts with a 2 is a B, right? So this is a straightforward red flag question. We didn't need anything in the passage. The math was easy. We're done. That should be the answer. Great. Let's move on to the next question. When the number of photons is doubled, the intensity of radiation is. This is also a red flag question. It's funny we've not used anything in the passage yet. But energy, when it comes to these waves, radiation, is H3, right? Planck's constant. I like to write as HF instead, because V sometimes I confuse HF. That's like frequency, right? Which is also Planck's constant divided by the wavelength. Another formula to remember, if I'm remembering this, intensity is going to be our energy divided by area multiplied by time, right? Now, I think the key to answering this question is when the number of photons is double the intensity of radiation, what happens to it? The intensity of radiation of Pacer, this Pacer system I'm talking about, takes into account every single photon, right? So there's a total intensity, but that total intensity comes from the total energy. It's additive, right? So if I have 4 protons of, say, energy 2 joules, then my total energy of radiation is going to be 8 joules, right? So basically, if the number of photons is double, so rather than just having 1 E, I have 2 E, like 2 times E, the number of photons times the energy, because now my total is 2E. That will give me double the intensity, right? Because this assumes the area, the time, nothing of that sort is touched. They didn't mention anything about area of time, right? So this is just being able to recognize that the number of photons gives you the total energy, which in turn gives you the total intensity. So now that I know this, when the number of photons is double, my intensity is going to double. And I remember you always try to get your answer before you look at the answer choices. There are a few situations where you have to look at your answer choices, but my answer should be A. I'm going to clear this, and so we can proceed. Let's see if it's right. A. right? That's very clear. So 70, what is the energy difference between photons with the highest and lowest wavelengths? Okay, so the question now detected by Phys, they're giving us Planck's constant. So the first question we ask ourselves, do we have the wavelengths anywhere, right? And they're asking for energy difference. What is our formula for the energy, right? We wrote the energy difference is going to be, the change in energy is going to be my energy for high minus my energy for low. The key thing, I mean, it's not necessary. You can still find the answer. It's just probably maybe going to be negative. But the key thing is when we're dealing with wavelengths and energy, it's inversely proportional. So I'd rather want to write energy low of the lowest wavelength minus the energy of the highest wavelength for that reason, just to keep everything positive, right? And we know that our energy is HF, and we know our frequency is going to be speed of light divided by lambda, right? And this is something we need to remember. These are equations we need to remember. So please, please, please remember these. Okay. Let me erase all of that so that we can continue working on this answer. So now that we know energy is our Planck's constant multiplied by speed of light divided by lambda, first lambda, the lowest lambda was 400. We have the same on top divided by 700. If I want to write it in a way that will make it easy for me to see, it's going to be HC multiplied by 1 divided by 400 minus 1 divided by 700, right? Okay. Now, we have 400 nanometers. So let's not forget that we have to convert all of these nanometers into meters, because that's a mistake people make, and I almost made that mistake. So we multiply this by 10 exponent minus 9, 10 exponent minus 9. If I pull that out, it's going to be HC multiplied by this, all times 10 exponent 9, right? So 10 exponent minus 9 in the denominator, when you bring it to the numerator, it becomes 10 exponent 9. Okay, so now that I've dealt with this, we have a fraction. What I like to do is, I like to take the numbers that are not multiples of 10. How do I explain this? Okay, scratch what I said. Think about the unique numbers that are not zeros first. So what do I mean by that? When I'm looking at this, I see 1 divided by 400 as 1 divided by 4. The zeros will deal with themselves, because even now looking at the options, they all end with 10 exponent minus 19, right? 1 divided by 4, 1 divided by 7, right? That's how I see. Now I know 1 divided by 4, 0.25. I don't know what 1 divided by 7 is. So I look for a number that is above and below the number in question. A number above 1 divided by 7, a number greater than 1 divided by 7, and a number less than 1 divided by 7 that I know. And these numbers happen to be 1 divided by 5, which is 0.2, and 1 divided by 10, which is 0.1. So now 1 divided by 7, I'll write it on top left here, 1 divided by 7 is going to be within the range of 0.1 to 0.2. This is 1 divided by 5, that's 1 divided by 10, right? I know it's going to be here. Is 7 directly in the middle of 5 and 10? Not really, but it's close. So I can estimate that, right? I could truly estimate that. You can estimate 0.14, you can estimate 0.16, you can estimate 0.15. I'll go with 0.15 because it makes my work easier. I'm seeing 0.25 here. So if I have a 0.15 here, it's easy for me to find out that the answer that I need, right? You see, you catch the drift, right? It will be easy for me. Now, because both of them are in the hundreds, that's 1 divided by 400, 1 divided by 700. I am confident that even if I find a difference between 0.25 and 0.15, it's going to be equal to the difference between 1 divided by 400 and 1 divided by 700. So 0.25 minus 0.15 is 0.1, right? This is how I work through math that is a little complicated. Make it easy for yourself. Look for the unique numbers. Forget about the zeros. Deal with the unique numbers first, and then come to the zeros. Usually it's easier than this, but you have to throw in 1 divided by 7. But using this range, I think we are good. So that brings my answer in the parentheses to be 0.1. And 0.1 is also, in fact, I want to write it like that to make this easier. 0.1 is also 10 exponent 1, right? So now we've dealt with every unique number. We are left with Planck's constant, which is 6.6. I'm going to write the exponent of 10 here. There's 10 exponent minus 34. And we have speed of light, which is 3, right? And I'm going to write that down, times 10 exponent 8. So you see what's happening. I've moved all my exponents of 10 to one side, and I'm dealing with only the unique numbers in there that are not exponents of 10. Why? Because if I can deal with those numbers, whatever my answer is in that region is going to point me to the answer on the MCAT. I don't need to get the exact value. I just need to identify the part of the answer option is that is different, right? So for example, in what I'm doing right now, I have 6.6 times 3. If I round 6.6 up to 7, 7 times 3 is what? 21. So 6.6 times 3 is approximately 21, and that looks like a 2.1. I don't have to worry about the 10 exponents. I don't have to worry about anything else. I've got my first number. I've got my first part of the scientific notation. And thankfully, in these answer choices, each of them is different. I don't need to do any extra work. So I'm going to go ahead. I'm going to clear my screen, and I'm going to choose A as my answer. Let's check it. That's correct. So you don't need to solve it till you get the exact number. Use estimates, but also when it comes to scientific notations, move your exponents of 10 to one side and deal with only the unique initial numbers in the scientific notations. Whatever those numbers give you should resemble or should be very close to one of the numbers you see in answer choices. The 10s will deal with themselves. There's going to be another question where probably also would have been 2.1 times 10 exponent 25, 2.1 times 10 exponent minus 19, 2.1 times 10 exponent minus, say, 30. And in a question like that, you know what you are focusing on. Your 2.1s are the same, but your exponents is different. So you focus your math on the part that is different so that you can arrive at your answer without having to solve every single line in that, work the math in every single line, right? But hopefully you learned something from this. I'll see you very soon. Let me know your feedback. Let me know how I can improve. Let me know what I can do. If there's any passages you want me to go through, feel free to drop them in the comment section. I'll be willing to go through those passages with you. All the best and enjoy yourself. Take a break. Breathe. All right. Bye.